Today we're going to be doing geometric sequences. The definition of a geometric sequence is a sequence of numbers in which the ratio r remains constant. The way you can find that common ratio is by dividing a term by its previous term. So you have to use the second term first and divide it by the first term. So first, we're going to determine whether the following series of numbers is actually a geometric sequence by trying to identify the common ratio. So what we're going to do is we're going to actually divide every number by its previous number in order to decide if there is a common ratio. So that will look like 10 divided by 2, which is 5, and then 50 divided by 10, also 5, and then 250 divided by 50, which is also 5. So since all of those are 5, then this is a geometric sequence, and the r equals 5. So you can write yes. When I taught this in class, I just had them write that it was geometric, and the r is 5. So you can have numbers like that are nice whole numbers, or this one is going to give you fractions because you're having to divide 45 by 135. And so when you do that, 45 divided by 135 is 0.3 repeating, which you can do math enter on your calculator and get 1/3. And then you got 15 divided by 45 is also 1/3. And you got 5 divided by 15, which is also 1/3. So this one is also geometric. And this time the ratio is 1/3. And so you can have fractions. You could have a negative number. Any number can be your ratio. It just depends on what happens when you divide. On this one, we've got 24 divided by 18. That's also going to give you a fraction. It's going to give you 4/3. And then when you do 30 divided by 24, you actually get a different number. So 30 divided by 24 is 5/4. That's what I thought, but I wanted to check and be sure. So this one, oh, I'm writing the wrong thing. This one is not geometric because those are not the same ratio. And then on this last one, we've got negative 14 divided by 7. That's negative 2. 28 divided by negative 14 is also negative 2. This is supposed to be an 8. Negative 56 divided by 28 is also negative 2. So each time you're dividing a negative by a positive or a positive by a negative, so that's going to keep that ratio negative. So this one is geometric, and the ratio is negative 2. Why did I write a 3? Okay. So that's how you determine if it is a geometric sequence and what the ratio is. Now, in the next section, it actually tells us these are all geometric sequences. So we don't have to go through all of that division. We just have to divide one time. So we're going to do negative 21 divided by 7. So just the second one divided by the first one. That gives us a negative 3. And so then we're going to use that ratio to find the next 3 terms. So what that means is, like, this is term 1, term 2, term 3. They want you to find term 4, term 5, and term 6. So the way that you're going to do that is you're going to do 60 for this one. You're going to do 63 times negative 3. Don't write that down. And so if you do 63 times negative 3, you get negative 189. And then you're going to do, for the next one, you're going to do negative 189 times negative 3. So that's 567. And then for the sixth term, you're going to do 567 times negative 3. And so that's negative 17 0.01. So every time to get the next term, you're just multiplying the previous term by whatever common ratio you found it to be. So that's what we're doing there, the purpose of that. The next one, we're going to have 768 divided by 3,072 to get our common ratio. So 768 divided by 3,072, that's going to give us 0.25, which is the fraction 1/4. And so then you're going to go up here and multiply 192 by 1/4 to get the next term. So 192 times 1/4 is 48. And then we're going to multiply 48 times 1/4. So that is 12, not point. And then 12 times 1/4 is 3. So that is how you do one with a fraction. So notice that the numbers here are going up. Now they are switching back and forth, negative and positive, because of the negative ratio. But these numbers are getting smaller. So as they go out this way, they're also getting smaller. So just make sure that you're paying attention to your numbers, that they follow that pattern. So if these numbers, like these, are going down, these numbers also need to be going down, and they are. These numbers were getting, larger and then switching back negative and positive, and these did the same thing. So you just need to be careful about that. Make sure that your numbers make sense. For this last one, we're going to do 4 divided by 8, which is 1/2, not 2. So I've had a lot of people on this one tell me that it's 2, but it's not, because you're not doing 8 divided by 4. You're doing 4 divided by 8. And so 2 times 1/2 is 1, and 1 times 1/2 is 1/2, and 1/2 times 1/2 is 1/4. And so you can easily do that in your calculator to get those answers. And then the last one here is -25 divided by -5, which is +5. So that means that we're going to multiply -125 by 5. And that's going to give you a negative number, because you have a negative times a positive. And so all of these are going to stay negative. Then -625 times -5 is -3,125. And then that times 5 is -15,625. Barely enough room to get all that in. Okay, so that's how to extend the sequence. On the next page, we're going to use the geometric sequence formula. So if you were asked to find like the 15th number in the sequence, you would not want to multiply by that ratio enough times to get to 15. So we have a formula here where we use A1, which is the first term. So it's like A stands for the term and 1 stands for that it's the first term. And then we also have a ratio R, which obviously stands for the ratio. So we've got those two pieces of information that give us the first term always. Like the first term in this first question is 3. So that's obvious. We have to find the ratio, and then we just put it together into the formula, and we keep the n's until they tell us what to put in for n. So n is going to be whatever number they want us to find. So right now, the common ratio, we would do 9 divided by 3, and so that's going to give us 3. So the common ratio is 3, and the first term is 3. Now that just is a coincidence. That does not always happen. So when we write this formula, we're going to have A sub n equals 3. So this is the first term 3 times 3. This is the ratio 3. And then that's to the n minus 1 power. So that formula lets us find whichever term we want. And so the term we want to find is the 7th term. That's what our directions tell us. So that means that for n, we're going to switch it to 7. So down here you can see A7 is already written, and so we're going to have 3 times 3 to the 7 minus 1 power. And so you can put it in your calculator just like that, or you can do 3 times 3 to the 6th power. You can go ahead and subtract 7 minus 1 and just have the exponent of 6. Some people really like to do that instead because it's a little bit less to type. And so that equals 2,187 when you type that into your calculator. So just this part after the AN part, or after you have simplified the decimal, or the exponent, not the decimal, one of those will go into the calculator. If you want to simplify the exponent, definitely put this one in your calculator. So that goes in just like it looks there. Okay, so now let's do the next one, common ratio. So we've got to do 20 divided by -4. That does not change from the other side. We're still doing that same step that we did on the other paper. And then the formula, we're going to have AN equals -4. That's from your first term, times -5, that's your ratio, to the n minus 1 power. And then for A7, we're going to have -4 times -5 to the 7 minus 1 power. Or you can go ahead and simplify that to -4 times -5 to the 6th power. Whichever one you want. You can type either one into your calculator. Obviously, you guys can do 7 minus 1 in your brain. So when you type that into the calculator, you get a pretty big number that I'm not going to have room to write. So I'm going to erase this last little bit that I did so I have more room. So it is -62,500. So pretty big number. Actually, it's a negative, so it's a pretty little number. All right. Next one, we're going to do 200 divided by 400. Which is 1/2, so that simplifies all the way down to 1/2. So then you're in your formula, you're going to have A sub n equals 400 times 1/2 to the n minus 1 power. And so for A7, that will be 400 times 1/2 to the 7 minus 1 power. So I'm going to show you how I would put this in my calculator, because I would just use the 1/2 as 1 divided by 2 instead of trying to make a fraction. So I would do, it's already in here, 400, and then in parentheses 1 divided by 2 to the 6th power, and that is 5/4. Or if you have a decimal on this, you can write the decimal at 6.25. So either answer is acceptable. In class, we, of course, wrote to the fraction. All right, the next one, we're going to have 5 divided by 1, which is 5. And so our formula is going to be A sub n equals 1 times 5 to the n minus 1 power. And then our A7 is going to be 1 times 5 to the 7 minus 1 power. And so in my calculator, I'm going to do 1 times 5 to the 6th power, which is 15,625. Now remember, this is a type of exponential function, so that's why these numbers are going up so quickly. All right, the next one, we're going to have -4 divided by -1, which is +4. And then our formula will be A sub n equals -1 times 4 to the n minus 1 power. For A7, that will be -1 times 4 to the 7 minus 1 power. And so I'm going to go over here in my calculator and do -1 times 4 to the 6th power, which is -4,696. I had a dyslexic moment. 4,096. And then the last one, -243 divided by 729 equals -1/3. So it gives you -0.3 repeating, which you can change into the fraction, -1/3. So the formula is A sub n equals 729 times 1/3 to the n minus 1 power. Down here, I have A sub 7, and so that's going to equal 729 times 1/3 to the 7 minus 1 power. So in my calculator, I'm going to do 729 parentheses, 1 divided by 3, close parentheses, and raise that to the second power, and that just equals 1. So that was all of those. Obviously, let me know if you have questions. Then on this last one, this table to the left shows a car's value for 3 years after it's purchased. Write a rule to represent the car's depreciation. Well, the first thing you have to find is the ratio. And so to do that, you're going to do 8,000 divided by 10,000 because you've got to do that second term divided by the first term, just like normal. And so 8,000 divided by 10,000 is 0.8, which changes to the fraction 4/5. So then when you want to write the rule for the depreciation, it's going to be just like writing the formula above. So you have AN equals 10,000 times 4/5 to the n minus 1 power. And then this time they ask you to use 10 for n. So we have been using 7 all this time, and this one asks you to use 10. So be really careful that you're paying attention to what the question is asking of you. So then for this, I'm going to type into my calculator 10,000 and then in parentheses 4 divided by 5. And then the exponent I'll use is 9 because 10 minus 1 is 9. And so after 10 years, the car will be worth $1,342.18. So it's in the calculator, it's 1342.17728. So since it's 177, that 7 is going to round that up to 8. All right, so that's everything for geometric. I'm going to make a separate video for arithmetic.